Hello everyone, this is video 3 of one-way ANOVA, and before we get into looking at some SPSS output, let's review video 2, what we went over in video 2. Um, so in video 2, we first made predictions about how conservatives, moderates, and liberals would differ on their levels of feminist prejudice. Right? And we already know from the independent samples t-test that conservatives reported much more feminist prejudice than liberals. So it's really thinking about considering how moderates would actually score on feminist prejudice when compared to liberals and conservatives. And we reasoned that because moderates are supposed to be in the political middle, right, the middle ground here, that they would score in between liberals and conservatives. And now also introduce you to a new graph here, a line graph. So if we connect the dots here, right, with lines, we get a line graph. So it is possible, it is feasible that we could just conduct a series of independent samples t-tests in order to assess the differences between our three groups here, conservatives, moderates, and liberals, on their levels of anti-feminist prejudice. But why don't we? Why don't we conduct a series of independent samples t-tests, right? And we would need to conduct how many tests in order to compare liberals, moderates, and conservatives? We would need to conduct, right, a series of three independent samples t-tests if we were to compare all these different groups. So why don't we? Why don't we conduct these three independent samples t-tests to compare all these groups? Well, if you remember, right, it's about type 1 error. And so type 1 error is when you conclude that there is a difference, right, when there actually is not if you got everyone in the population. And so for any given t-test, the percentage chance of making a type 1 error is 5%. That's right. But we'd actually need to conduct 3 independent sample t-tests in order to compare all 3 groups here, liberals, moderates, and conservatives, on their levels of anti-feminist prejudice. So we can't consider these independent samples t-tests in isolation. These 3 groups are under the same independent variable here, political orientation. So we actually need to multiply that 5% by 3. So the chance of making a type 1 error would actually be 15% for these series of t-tests. And ANOVA, right, keeps the type 1 level, the type 1 error level down to 5%. We also talked about another point here about how else ANOVA is advantageous, beneficial, preferable to doing a series of independent sample t-tests. Right, and the second big advantage is that because we include everyone, liberals, moderates, and conservatives, in the same test, right, we better estimate our error term and S-pooled. Because conceptually, we talked about how increasing sample size affects our error term. And so we know that increasing sample size decreases our error term because if we include more people from the population in our sample, our estimates of what's going on in that population should be more accurate. Then we moved on to talk about sort of the general approach to interpreting ANOVA, right? And so we learned that the inferential value for ANOVA is not T, but F, right? Uppercase F. And again, I don't know who determined that the inferential value for ANOVA should be uppercase F, but that's what it is, right? And we know that F values range from 0 to positive infinity, so there can never be a negative F value. If you get a negative F value in SPSS, something went horribly wrong. And so if our F value is significant, then what does that tell us, right? Because ANOVA is assessing simultaneously all the differences between liberals, moderates, and conservatives, right? So our F value is significant, then that means there's at least one significant difference between our different groups. And then we need to check post hoc tests to determine which groups significantly differ. SPSS also calls them multiple comparisons. Right? And there are a variety of different post hoc tests you can use in SPSS. If you actually, conducted ANOVA, there'd be over 20 different post hoc tests that you could choose from. In our case, we are going to use which type of post hoc test? Bonferroni, right? Bonferroni sounds like a pasta, but we use Bonferroni because Bonferroni best adjusts for type 1 error. So I have a video where I conduct a one-way ANOVA, actually on this example, looking at the differences between liberals, moderates, and conservatives on the differences in anti-feminist prejudice. And again, this YouTube video is very handy for learning how to conduct a one-way ANOVA in SPSS, but it is also beneficial because I not only teach you how to conduct it, but I interpret the output just as we're going to do in this PowerPoint. All right, but this video, you should watch this video assuming that you've already gone through this lecture and and already have some basic fundamental knowledge about how to interpret ANOVA. And again, for practical 3 was supposed to be all about conducting one-way ANOVA, but it looks like we're going to be learning online remotely for the entire semester. So it's more likely that practical 3 will be more like practical 2, in that I will conduct the one-way ANOVA for you and give you the output, or at least give you different sets of output, and you have to choose the correct one. So let's start reviewing the output, including first checking assumptions, right? And so there's something new that we need to check with one-way ANOVA, and that is Cook's D. So I know Cook's D here. We have Cook's D, capital D, uppercase D, which is different than Cohen's D. So Cohen's D, lowercase d, small d, is effect size for a mean difference. Here, Cook's D, capital D, is something entirely different. And so when you actually conduct a one-way ANOVA in SPSS, following my directions in the YouTube video, you will get a new variable in the data set that is COO_1. And so this stands for Cook's D values. And so every single participant gets a Cook's D value in the data set, right? And so if we conducted another ANOVA, we would get another column here that's like COO_2. If you conducted another ANOVA, right? So this is the first ANOVA that we're conducting in the data set. So we have COO_1. And so every single participant gets a Cook's D value. And I have sorted these values descendingly in the output, that is from largest to smallest. And ultimately, Cook's D help us spot potential outliers. And so let's talk about how Cook's D values do this, right? So as I said, every participant gets a Cook's D value. And these D values indicate how much each participant affects the inferential stats if they are removed from the analysis. So SPSS is sort of simulating, all right, I'm going to take this participant out, I'm going to run the ANOVA, and then I'm going to calculate this value that tells us how much this participant would affect the inferential stats if they're actually removed from the analysis. Now, if we think about, right, outliers, right, outliers excessively change our descriptive and inferential results, right? Outliers are bad, outliers suck, right? because they shift, right, change our descriptive statistics, right, especially our standard deviation, right? And our standard deviation is so integral in calculating our error term and our inferential value. So no participant, right, should excessively change our results, right? Because outliers do this, right? Outliers excessively change our results. So are bigger or smaller Cook's d-values more problematic? Right, so if each of these Cook's d-values represents how much a participant affects the inferential stats, and no participant should excessively change our results, right? We want smaller d-values, right? We want smaller d-values, so bigger d-values are more problematic. So after we sort these d-values descendingly from biggest to smallest, we're actually looking for really big jumps in between the numbers, right? So if we see here, we have a nice progressive gradual decrease in Cook's d-values from 0.05 to 0.04, 0.03, 0.02, 0.01. That's what we want to see, a nice gradual decrease. Now, if we saw, for example, for this first person, if we saw a Cook's d-value of like 0.5, and then it went to 0.05 for the second participant, then that looks like there is a problem, right? It looks like that first participant may be a potential outlier. So if a person has a big Cook's d-value, then we would remove them from the analysis, rerun the ANOVA, and then we would compare the results. And so we talked about a similar approach when we first talked about outliers, that we take that person out, rerun our analyses, and then compare the analyses with and without the potential outlier. And so if there's a big change, then that's something that we should consider, and we should probably report both sets of results. All right, so you have to first check your Cook's d-values, and if your Cook's d-values look good, then you can move on to checking your other assumptions, right? And so we've talked about all these different assumptions, right? So we want to make sure that our continuous distributions approximate normality. So our feminist prejudice scores are a continuous variable, so we want to make sure that those scores approximate normality. We want to make sure that we have enough liberals, moderates, and conservatives in our data set that we meet the equal cell size assumption. And so I will say that I've already checked the normality of prejudice scores. They look good. And then, as you can see, we have pretty similar numbers of liberals, moderates, and conservatives in our data set, 35 liberals, 42 moderates, and 45 conservatives. So we meet the equal cell size assumption too. And just like for the independent sample t-test, we have the quality of variance assumption that we need to meet for our between subjects ANOVA. And so if you look in the upper right-hand corner here, you see that we have Levine's test of equality of variance. So again, this is testing to make sure that the standard deviations for the independent groups are similar enough, right? So we have three standard deviations here because now we have three independent groups. When we conducted the independent sample t-test, right, we only had two. Here we have three standard deviations, right? 1.77 for liberals, 1.91 for moderates, and 1.89 for conservatives, right? And so Levine's test is assessing whether these standard deviations are similar enough. And so we want to zero in on the significance value for Levine's test. And so we want Levine's test to be non-significant, right? Because that would mean that these standard deviations are non-significantly different from each other. And we see that Levine's test, the p-value for Levine's test is 0.917, 0.912. And so we are far away from the criteria of significance of 0.05, right? So p-values that are less than or equal to 0.05 are significant. In this case, Levine's test is non-significant. That's great. That means the standard deviations are similar enough And that means that we can go on and interpret, we can go on and go to the meat of the analysis, the main part of the analysis. Right. But first, we can sort of check out the data first here. We can check out the mean scores to get a sense of what's going on. Right, so if we take a look at the mean scores here between liberals, moderates, and conservatives, right? I mean, we notice that big difference between liberals and conservatives here, with conservatives having a mean of 5.8 versus liberals 4.28, right? We know that conservatives already report much more prejudice, feminist prejudice, than liberals, right? The question was, well, how do moderates fit in the picture here, right? And we see the moderates means prejudice score here is 4.31. And so that doesn't seem very far away from liberals, but it does seem very far away from conservatives, right? So it looks like liberals and moderates may not significantly differ here, but it definitely seems like moderates and conservatives will significantly differ. It seems like moderates are scoring more on par, more similar to liberals than conservatives. But we have to check out our ANOVA test. We have to check out our F value. And then if we get a significant F value, that means there is at least one significant difference between our groups here. And then we have to check the post hoc tests. And so that's what's coming up in the next video. We're going to get into the output, the main output here to see what's going on between liberals, moderates, and conservatives. So that's what's in the next video, and stay tuned.